Okay, so we're going to look at another one here. This is where we're just going to be asked to find what V out is. So find V out in the circuit shown below. So I should draw the circuit. So this is 240 at an angle of 0 degrees, volts. And we have a J 10 ohm inductor. $50 ohm resistor, J 10 ohm inductor, $30 ohm resistor, and then this is V out that we're looking for here. Now, again, you can kind of use any analysis technique, but I'm going to go ahead and use nodal. Now, first thing we should notice here, we're looking for steady state. First off, everything's been given to us in impedance form already, or in polar form, or in really what I'm trying to say is we all have phasors. So everything, this is already in phasor form. So in phasor form. But this also means, since it's already in phasor form, we don't have any idea what omega is. Okay, so we don't know what omega is, but that's not a big deal. We don't need to know that. We have everything else here that we need. So again, I'm going to go ahead and convert everything to rectangular. So when you see something at an angle of 0 degrees, you should love that, because that just becomes 240 volts in rectangular form. Alright, so then let's go ahead and look here. So we have, let's identify our nodes, just kind of like what we did before. So we have a node here, node here, node, node. We know that this node is 240 volts because ground is here, but I don't know the voltage here, and I don't know the voltage here. But we do, of course, know that VB is simply equal to V out. Now, you could also solve this problem using loops if you wanted to. I'll kind of draw them in here. You could do I1, I2, figure out what I2 is, and then do I2 times this resistance. And if you did that, you would figure out what the voltage is as well. That is definitely a way to do this, but I am going to do the nodal analysis, and the reason I like that is because it directly gives me the voltage that I'm looking for in this case. And as far as the number of equations, it's the same number of equations in both cases. Alright, so remember, doing nodal, we just look at the currents leaving the node, and so we'd have here VA minus 240 over J10 ohm plus VA over 50 plus VA minus VB over J10. And this is equal to 0. Now, I am going to simplify that in a second, but because I'm going to have to scroll past the circuit here, let's go ahead, that's my node equation there. Let's go ahead and look at the node equation for the other node here. So I'd have these two currents here, and so you'd have VB minus VA over J10 plus VB over 30 is equal to 0. So I'll still do the simplification one equation at a time, but I just wanted to get both those equations written down because I'll scroll the circuit out of view here. Alright, so let's look at the VA minus 240 over J10 plus VA over 50 plus VA minus VB over J10 equaling 0. Well, it makes sense that we're going to clear that denominator out, and I think the most thing makes sense to do is multiply by J50. So I don't make arithmetic errors. I'm going to be careful here. So J50 divided by J10 would be 5, and then VA minus 240. And then this would be plus JVA plus 5 times VA minus VB. And so we'd have 5 VA minus, well, what's 5 times 240? It should be 1200, and it is 1200, plus JVA plus 5 VA minus 5 VB equals 0. And so combining terms together, as long as I do this carefully, I'd have 10, 5 plus 5 is 10, plus a JVA minus 5 VB is equal to 1200. Alright, so then that's my first equation that I would need. And then I'm going to, of course, need a second equation, and I've already gotten that down. It's VB minus VA over J10 plus VB over 30 equals 0. And then, of course, we'd want to clear out here, multiply by J30. And if I multiply by J30, again, just being extra cautious, I'd have 3 times VB minus VA plus JVB equals 0. And this one's not as difficult to be careful with, so we'd have minus 3 VA plus 3 plus J VB. And so this would be my second equation. So I've got 2 equations and 2 unknowns. And so again, depending on your calculator, you might have to set this up, and I'm going to again set this up as if we had a calculator that you couldn't plug complex numbers in. So this would be 10, 1, negative 1, 10, and again that's for this. And then for the negative 5, you'd have negative 5, 0, 0, negative 5. 1200 would be 1200, 0, 0, 1200. And then the next equation, well, I've got negative 3 VA, so negative 3, 0, 0, negative 3. And then this would be 3, 1, negative 1, 3, and then a bunch of zeros. And then again, you RREF this, and I'm going to pause the recording here. And when I get that, I'll just write down what I get for VA and VB. I get that VA is 180.82 plus J, it's not plus, it's minus, minus J 82.19, and then VB I get as 138.08. I'm sorry, let me see here. Is that right? I'm looking through my calculator here. Yeah, minus 128.22. And these are both in volts. And so, of course, this here is my answer. And, you know, we always said that we want to write my V out in terms of, you know, like a Vm cosine omega t plus phi. Now, remember, we don't know omega, but we can still write answer in correct form. What do I mean by that? Well, convert to polar. So if I do 138.08 and I left my j out there, minus 128.22 j, and then I go to my math menu, convert that to polar, I get that VB is 188.43 at an angle of negative 42.88 degrees. And so I can write my V out, because V out is equal to VB, remember. V out would be 188.43, and I don't know omega t, so I just write, I don't know what omega is, so I just write omega t minus 42.88 degrees, and this is in volts. So even though I don't know omega, I can still write it in the proper form. Okay? Alright, so we probably will still have a few more examples that we go over here, but the key thing you want to remember from this video and the previous lesson is being able to solve complex systems of equations. Now there are other ways to solve them besides using matrices. There's something that's called Cramer's rule that you can use. I find matrices to be the simplest method, and we all are allowed calculators that can do matrices. So now I know, as I said, if you have like the TA89 or the TI Inspire, I think will let you just plug the complex numbers in directly, but I use the 84, so I always like to show people how to do that using this kind of matrix.